Today we will react a standard solution of sodium hydroxide with a sulfuric acid solution to determine its molar concentration.
A standard solution contains a known amount of solute, so all the bottles of sodium hydroxide are marked with the concentration.
We want to find the exact volume of sodium hydroxide needed to react completely with sulfuric acid.
Both the reactants and products are clear, making them hard to tell apart, so be attentive when obtaining your solutions.
This is a neutralization reaction, so we're adding sodium hydroxide to sulfuric acid, causing a change in the pH.
When all of the acid has reacted with base, we are left with products of salt and water. The pH is neutral.
If we use an indicator, the color in the reaction flask will change as the pH changes. The color change is the end point of the reaction and lets us know when to stop adding base.
Get a burette, pipette, and pipette pump from the cart.
The pipette is cleaned with water and conditioned with reagent before using. Remember to hold the pipette firmly at the top when attaching the pipette pump. See the how-to pipette video for more detailed instruction.
There is enough sulfuric acid solution in this beaker for all the trials of this experiment. A little is used to condition the pipette. Remember to handle acids with care.
Now, measure the 10.00 milliliter of sulfuric acid solution into the clean reaction flask. Remember, never pipette out of the stock bottle.
Add 20 milliliters of DI water and a couple drops of indicator. This flask is now ready for the experiment. You will prepare 2 more flasks like this later in the lab. We'll set this flask out of the way while we prepare the burette.
The burette is cleaned with water, just like the pipette. Then, conditioned with the sodium hydroxide. Always fill the burette below eye level or below the eye level of the shortest person near you. Lowering into the sink makes this easier. Sodium hydroxide is corrosive, so handle with care. Now we fill the burette. Lifting the funnel helps to prevent overfilling.
Open the stopcock to drain some solution again. This makes sure there are no bubbles.
The starting level should be between 0.5 and 0.00 milliliters. It doesn't matter if you're off a little as long as you record the initial volume to 2 decimal places.
The initial volume looks like 0.12 milliliters. See the How to Use Graduated Glassware video for more information of reading the volume of a burette. We keep this stoppered between trials to keep the sodium hydroxide from absorbing carbon dioxide from the air.
Be sure to get the burette seated into the grooves of the clamp so it is perfectly vertical. We are now ready to titrate.
A white paper will help us see the color change.
You can add 1 to 2 milliliters of sodium hydroxide at a time and swirl.
Or you can adjust to a steady state of drops, swirling constantly. You can try either method. Just remember to add less sodium hydroxide at a time as the pink color starts to linger in the flask.
Continue adding sodium hydroxide until the faint pink stays after swirling for 30 seconds. If the pink goes away, you have to add more sodium hydroxide. You can lift the flask to touch the tip of the burette to catch any hanging drops.
You may want to record the volume when you think you're getting close to the end. If you add too much, you will see hot pink in the flask, and you may have to repeat the trial.
The faint pink color indicates the end point of the reaction, and we record the final volume. I see 29.08 milliliters.
Always record 2 decimals, even when the meniscus is touching a line. If it does touch a line, just record 0.00 for the decimals. The flask can be emptied down the drain and cleaned to prepare for the next trial.
Refill the burette with sodium hydroxide between trials. After completing all 3 trials, rinse the pipette and the burette in the sink, and then return them to the cart.
All other glassware is washed and returned to the drawer.
You will calculate the total volume of sodium hydroxide used in each trial. Using this and the molarity of the sodium hydroxide from the bottle, you calculate the moles of sodium hydroxide used.
With the moles of sodium hydroxide and the balanced neutralization reaction, you can calculate the moles of sulfuric acid and use that to get to its molarity.
Titration takes some skill, but the trials will go quickly once you get the hang of it.
Have fun in lab today.